Hi everyone, this is Ellen from the Astrology Journal. So in this video, we're going to go over how to convert decimal degrees to degrees, minutes, and seconds. And actually, before we do that, we're going to go over the reverse, how to convert degrees, minutes, and seconds to decimal degrees. And the reason we want to do that is just to go over it one more time, because I think the more you hear it, the easier it's sort of, the more it just is like, yeah, that's what we're doing. So we start out with where we're calculating time. We want to get the event time that we're given, and we want to convert it to the sidereal time that the planets, that's the time that the planet positions are recorded in. So the event time is given to us in tropical time, and that's different than sidereal time. So we start with the event time and date. We want to convert that to sidereal time. And then we want to convert that sidereal, well, let's just do this. So we have the event time and date. The first step, that's tropical time. First step, convert it to Greenwich Mean Time. We're still in tropical time. We've just shifted the time zone. So where it's now as if the event happened in Greenwich Mean Time, kind of that location. And so then once we're at Greenwich Mean Time, we can calculate it, we can convert it to sidereal time, but we're still in Greenwich, or the Greenwich Mean Time, you know what I mean. And so, although I'm not sure I know what I mean, but anyway, so we convert that to sidereal time, but we're still in the Greenwich time zone, and we want to convert it back. We want to now get that sidereal time so that we have the sidereal time for the location. And the way that we do that is we take the longitude, and the longitude is either how far east or how far west a location is from Greenwich. And we want to take that distance and we want to convert it to a time. It's called longitude time equivalent. And longitude is given to us either in degrees, minutes, or degrees, minutes, and seconds, or in decimal degrees. If you Google search it, you'll probably see both. If you use the American Atlas, it's one of the resources I recommend, you will see it in degrees, minutes, and seconds. If you use, there's also a spreadsheet that you can download that's available it's free, it's available for anyone to use. That lists a bunch of locations with latitudes and longitudes. Those are in decimal degrees. So depending on the source you're using, you may have degrees, minutes, and seconds that you're working with. You may have decimal degrees that you're working with, or you may have a choice. So it's good to know how to work with either possibility that you may come across. So what we've been working with this number, 132 degrees, 54 minutes, and my finger is wet, and 54 minutes and 26 seconds. Oops, 20. I'm going to pause this for a second and just wash my hands and dry them off so that I can do this so you can see it. Hang on. Okay, I'm back. So let's get rid of that. Oops. Here we go. Okay, so we have 132 degrees, 54 minutes, and 26 seconds. We'll just cross that out. And so we'll just start here. What if this is what we have, and for some reason we want to convert it to decimal degrees? And there are reasons you might want to do that. So I'm going to get rid of my webcam, and so we have a little more space. So we need to, what are we doing when we're converting to decimal degrees? Essentially, we're saying we have a whole degree, we have a whole number for degrees, and then we have these partial parts, then we have a part of a degree. So 54 minutes and 26 seconds is saying this isn't quite a degree. We haven't quite reached a degree. So we want to consider these as portions of an hour. And so, and so we can talk about percentages. If 54, say, was a regular number and we wanted a percentage, we're working in the base 10. And so we would, we would divide that by 100, and we would get the percentage, what percentage of 54, what percentage of 100 is 54, and that would be 0.5 something. And we can just do it. We don't need to do it, but you get the idea that, so what we're trying to do is figure out what percentage of 100 is 54, and we just do the math. We divide 54 by 100. But here we're working in base 60, and so we would divide 54 minutes. There are 60 minutes in an hour, so we would divide 54 by 60, and that gives us this is actually really easy. That gives us 0.9. So we end up 60 times 9 is 540. So that gives us 0.9. So we have 132. That's our hours. And then the portion so far, the minutes are represented by that 0.9. We need to figure out the seconds. And what are the seconds? Well, the seconds are also part of an hour. But the seconds there are 3,600 seconds in an hour. So there are 60 seconds in a minute, and then there are 60 minutes in a second. So that means 60 times 60 is an hour, and that's 3,600. So there are 3,600 seconds in an hour. So 26, what we're going to do is we need to divide that. 26 divided by 3,600. I'm actually going to do this on another sheet. So we're going to have 26 seconds divided by 3,600. And so we can't obviously divide, 3,600 doesn't go into 26. It doesn't go into 260. It doesn't go into 2,600. It does go into 26,000. So we start with a decimal. We know that we can't do anything there. We can't do anything here. So then we figure out how many times does 3,600 go into 26,000. And that's just a matter of figuring out the math. So we can do 7. I know this. It would take me a long time to figure that out. Actually, that wouldn't be easy for me. But 7 times 0 is 0. 7 times 0 is 0. 7 times 6 is 42. And 7 times 3 is 21 plus 4. That's 25. And 0 and 0. And then 6, 5. And that gives us 8. So we end up with 800, and then we'll just add another 0, and so that we can go a little further. And so 3,600 goes into 8,000. This is easier. That's that's actually 2 times. So 2 times 0 is 0. 2 times 0 is 0. 2 times 6 is 12. We add 1. 2 times 3 is 6, 7. That something isn't right there. That is right. So we get 0, we get 0, we get 8, we get 7 here, we get 8. So we end up with 800 again. So we're just going to keep getting 800, and so we'll just keep getting 2 like that. So the seconds are represented by 0.0072. And the minutes are represented by 0.9. So we can add those two together, 2709. And this is a decimal part of our number. So we had 132 is the main part, and the decimal part is 9072. And then we can confirm that we got the right answer. So we can take 132 degrees, 54 minutes, and 26 seconds, and that gives us 132 degrees, 54 minutes, 26 seconds, and that gives us 132.907222. So we've got the right number. So this is a decimal degree equivalent to the longitude. And what we can do, we can just go through the steps. So now we can take that, and we can do everything we need to do except the final step. So let's go through this. So we can take 9072. We can multiply the first step in converting the longitude to longitude time equivalent is to multiply by 4. So we take this number, multiply by 4. This is easy. It's just straight math. 4 times 2 is 8. 4 times 7 is 28. 4 times 0 is 0. Plus 2 is 2. 4 times 9 is 36. 4 times 2 is 8, plus 3 is 11. 4 times 3 is 12, plus 1 is 13. And 4 times 1 is 1, and that is 5. So we get 531.6288. So this is the number that we now need to divide by 60. 531.6288. So we'll do that on a new screen. 531.6288 divided by 60, and that gives us 8 times 6 is 48, so 8 times 0 is 0, and then that's 48, and that gives us 1, 5, 4, and so 8 and 5 is 13, so that gives us 51. We pull down the 6, and that gives us another 8.8. 8 times 0 is 0, and then that gives us 48. We get 6, we get 5, 4, 11, and that gives us 3. We pull down the 2, 60 into 362 is 6. 6 times 0 is 0, 6 times 6 is 36, and we get 2. We pull down the 8, 60 doesn't go into 28, so we get a 0. We pull down the other 8, and we get 4. So 4 times 0 is 0, 4 times 6 is 24, and that gives us 48 left over. If we wanted, we could go one more. So we just add a 0 and we go one more, and that would be 6 times 8 is 48, so that gives us 480. So we could do that if we wanted, and so we could round that up, 8.8605. So this is our longitude time equivalent. And so the question is, so then what we have to do with that, 8.8605, that's the longitude time equivalent. And we, oh, by the way, we can check that real quick. We can check our work. So we can use a calculator. We can take 531.6288 divided by 60, and that get that works, 8.86048, and that's what we got. 8.86048. So we got that. So we're in good standing. And then we take this number. And so what do we need to do with that number? Why did we convert longitude to longitude time equivalent? So that we could add or subtract that number to the Greenwich sidereal time to adjust it back to the event location time. So we can take, the question is, so let's say the Greenwich sidereal time was 3 hours, 12 minutes, we'll say 16 seconds. It's totally random. And let's say that we decided we need to add this to this number. Well, to this time? Well, how do we do that? We have degrees here and we have hours, minutes, and seconds here. So we'd have to convert this back to, in this case, for decimal degrees to hours, minutes, and seconds, because now we're working with hours, not degrees, because we converted the degrees to hours. So we need to figure out how to convert this back. So we know that 8 is the hours. And the question is, what are the minutes and seconds? Well, we essentially just do the reverse of what we did before. We take this 0.8605, and before we divided by 60 to get the hours, to get the minutes, the decimal minutes. Now we're going to multiply by 60 to get the full minutes. So 0 times 5 is 0, 6 times 5 is 30, 6 times 0 is 0 plus 3, 6 times 6 is 48, and that's 48, that's 52, and we have 1, 2, 3, 4, 1, 2, 3, 4. So we have, did I do this right? 0, 6 times 5 is 6 times 5 is 30, that's 3, 6 times 6 is 30. Oh, yeah, no, I totally didn't do it right. This is 30. 6 times 6 is 36. 6 times 8 is 48, 49, 50, 51. That makes more sense. So 51, and this is, by the way, why I'm not good at math, because I make those really simple mistakes frequently. So 51.63. So we know, so we'll take this whole number here, and that's our minutes. And now we still have to get the seconds. Well, before we divided the seconds by 3,600, But this time, we've already multiplied this decimal by 60. We just have to multiply this remaining decimal by another 60. 60 times 60 is 3,600. This is going to get us the seconds. So 0.6300 times 60 gives us 0.606 times 3 is 18. 6 times 6 is 36.7. So that gives us 37.8. We can round that up to 38. That gives us 38 seconds. 8:51:38. And if you remember, that is the time we got before. And again, we can check that. So 132. We'll just do, I'm not remembering the decimals, but we can just do 130. It's going to be the same. 132 degrees, 54 minutes, 26 seconds. That gives us the decimal degrees here, 132.907222. We multiply by 4. That gives us 171.62888. We divide by 60. That gives us the 8.860481. So we take that 0.8604, we'll say 0.8605, 0.8605, we multiply times 60. That gives us 51.63. So we got that. And 51.63. So that's where we're at. And then we take that clear 0.63 and we multiply that by 60 again, and that gives us 37.8, which is again what we got, 37.8. So we did that right. And then we need to, so we'll just say in this case, we're having to add the longitude time equivalent to the Greenwich sidereal time for the Greenwich location, Greenwich Mean Time location. Not mean time. I don't know. I actually have to look that up and find out what the actual official term and terminology is. I don't know. So anyway, so we're going to add it. So then we just do this. 8 and 6 is 14. 3 and 1 is 3, 1, 4. That's actually 3 plus 1 is 4 plus 1 is 5. So that's 54. And that's 3 and 6. And this is 8 and that's 11. But we want to convert the 63 to an hour because we want to have just the minutes here and whatever's left over to be an hour. So minus 60, and that gives us 0.3, and we add that one here. So we wind up with 12 hours, so noon, 0.3 minutes, and 54 seconds. And we can check that, make sure we've done it right. Clear, so we get 3 hours. So you just do degrees. The degrees is the hour. You can use degrees, minutes, and seconds, and hours, minutes, and seconds in terms of calculation. It's the same formula, the same thing. So if you have a degree calculator, you can use it for hours, minutes, and seconds. 3 degrees. Why? Because there are 60 minutes in an hour. There are 60 minutes in a degree. Okay, so 3 degrees, and then 12 minutes and 16 seconds plus 11 hours, incorrect, 8 hours, 51 minutes and 38 seconds. And that gives us 12,354. Is that what I got? I think that's what I got. 12,354. So that's our number. So that's how you convert longitude to longitude time equivalent using decimal degrees. And in the previous videos, we looked at how to do it using degrees, minutes, and seconds. So I hope this is helpful. If you have any questions, ask. I'll do my best to answer. Math is not my strong suit, but I feel like I figured this out. I will put resources, the videos to Christopher Stevens' videos on how to multiply and divide degrees, minutes, and seconds, and then I'll look for what I found to help me know how to convert decimal degrees to degrees, minutes, and seconds, and the other way around. Try to put those there. And then if you have questions, ask. I'll do my best to answer. If there are people out there who know math really well and you want to step in and answer a question, that's great. I think that's all. Thank you. I hope this was helpful. and we'll come back. So we're not actually going to do this step for until either the next lesson or the lesson after that. But I thought my thinking was that if math is challenging for you, this gives you an opportunity to learn how to do it before we actually get there. And I believe I'm going to include this math stuff in with the first time step, which is very easy. It's just converting the local time to Greenwich Mean Time. Really simple to do, and I figured this could be the next, get you thinking about this before we go on to the next steps. Okay, that's all. Thank you for listening, and I'll be back with the next lesson. Okay, bye.